Hello guys and welcome. Thanks for following along. So we are ready to create our local cluster, and we are going to use the super powerful command Genesis create-cardano from the CLI. This is a extremely powerful command basically because it produces everything you will need to create and maintain your cluster across the different eras. So it will produce the Byron Genesis file, the Shelly Genesis file, the Alonso Genesis file, the configuration file. It will produce the Genesis keys, the delegate keys, the UTXO keys for the supply that you want to have in your system. It will also even handle the hashing of the keys and the Genesis files to put them into the correct places, including the configuration file. So it handles everything for you. It's super powerful. It has some limitations and restrictions, but it is super powerful and very easy to use and easy to understand. This is why we are choosing this command to start this topic. And well, let me move on a little bit. You will need to take some decisions about the parameters, and we will talk about that in a minute. But the very first input that you will need is the so-called template files. What is the template files exactly? Well, we are talking about the template files that contain the parameters that your system will have for Byron era, for Shelly era, and Alonso era, together with the configuration files. So what it means is that we will get these template files from somewhere, right? So we will get them from the Cardano World repository. These are the very same template files that IOHK uses for deploying new clusters. But we are not going to use them right away as they come. We are going to tweak them a little bit to fit our needs because we are in a testing environment. I'm assuming that I'm going to test something, integrate something into Cardano. So I want this local cluster so that I can test it. But I want some changes. And these changes are what we are going to talk about in a minute. But before we talk about the changes, let me just get those templates so that we can later change them. So what I'm gonna do now is let me just delete my directory because I'm just doing some testing so I can start from a clean slate, and I'm gonna create a cluster directory and inside of it a template folder so that I can put my template files here. And for those of you that are curious, Cardano environments testnet template, and these are the very files that I'm going to download right now. So I'm gonna get them with wget. Please bring me these files here, and there you go. So these template files are like the Genesis files that you might be familiar with, but they only contain the parameters, not any mappings of keys or everything. That's what we are going to generate when we run the Cardano create command, the create-cardano command. So some decisions that I need to start taking about my system. My first decision is that I wanted to have only 2 block producers nodes, and I want to create a directory for each of those nodes so that I can put their configuration files, the keys and everything they will need inside of those folders. And together with it, I'm going to create a configuration folder so that I can put all the Genesis files, the configuration files, and all of that will be shared across all the nodes in the system. Later on, we'll be adding a stake pool, for example. It will share the same configuration files. So now, let me move on a little bit. I'm going to create the topology files for my nodes. So these 2 nodes, one will run in port 3000 and the other one will run in port 3001. So, of course, we want them to talk to each other. So BFT0, this is how I named my first node. It will be contacting BFT1 at port 3001. And BFT1 will be contacting BFT0 at port 3000. So I am creating the JSON files that represent this topology. I'm going to use classic topology for now. We are not going to mess around with P2P topology. That's a matter for another video. But for now, we are fine with just classic topology. So we're ready to start talking about our template files and how we want to tweak them. And again, here are more decisions that we need to take. My first decision is that I want shorter epochs. I don't want to wait 5 days for an epoch to complete, which is the parameter in mainnet, and I want shorter epochs, right? So how can I tweak that? Well, one could think that it is a matter of modifying for example, the Byron Genesis file, the Byron Genesis template, but it is not really. It is not really. Parameter that we have inside the Genesis file for Byron era considers only slot duration but not epoch length, right? We don't have any parameter here that talks about epoch length. We have a slot duration. So you would say, oh, probably if you make very quick slots, you could make it shorter, but that's not the way that we will take. This is not how it will work. So let me just a brief reminder that in mainnet, in Byron era, we had like 20-second slots. Now, since Shelley, we have 1-second slots. In Byron era, every slot had a block on it. That is the reason for it to last 20 seconds. We needed to ensure that every block had sufficient time to travel the world and reach other nodes. But now, since Shelley, we have what we call the active slot coefficient, which is the proportion of slots that will actually contain a block on it. And right now, the parameter is set to 5%. So that means that roughly 1 out of every 20 slots will have a block on it. So that is on average, of course. We might have slots, blocks that are closer to each other, and we might have blocks that are further apart to each other. So it is on average. So if you notice this, we have like a 20-to-1 ratio here, and this ratio is maintained by the create-cardano command. So it tries to mimic this ratio that we had on mainnet. And so by changing the epoch length of one era, I will be impacting the epoch length of the other, because we are trying to keep this relationship, this ratio. And Byron epochs last 10 times the security parameter, that is 21,600 slots. Now, because of the ratio that we just talked about, since we have shorter slots, but we want the epochs to last the same time in seconds, we multiply that so that Shelley epochs will have 20 times more slots than the Byron epochs. So if I change my security parameter to 45, so that my Byron epochs will last 450 slots, and my Shelley epochs will last 9,000 slots. How long will these slots last? Well, that's a topic for later in the actual running of the create-cardano command. Start modifying my Shelley JSON file so that I modify the security parameter, and together with it I'm going to modify the protocol version major to set it to 2, and that is because we already know that in mainnet the Shelley era had a version 2.0, so we are going to stick with that so that we are using the same protocol versions that we are using on mainnet, so that we don't have a brain freeze, at least I won't. Apart from that, I'm going to change the update quorum parameter, and that is because, well, I will only have 2 block producer nodes, so I want the quorum in Shelley era voting proposals to be only 2, because I couldn't have 3. However, the internal logics of the create-cardano command will give me a result of update quorum of 1, given that I only have 2 pools, 2 block producers, 2 delegate keys. But that doesn't seem right. That only 1 key has the potential to change the system, so I will require full consensus on my system to be able to update it, and that is from Shelley era and onwards. This is where this parameter takes place. So now I'm going to run this so that I change these parameters that I just talked about. Now the next thing I want to do is configure a little bit my configuration template. And basically I'm going to remove all the functionalities. I'm going to disable these functionalities that allows us to test hard forks without actually having the update proposals in there. This is for development purposes. It's also very helpful. But for now, since the goal or one of the goals of this video is to understand how in practice update proposals work, well, I'm going to disable this, and I'm also disable P2P topology, and I'm going to keep mean severity at info level, not in debug. Okay, so this is a good starting point for me, and I am ready to create Cardano. So let's talk a little bit about the options that this command takes and what they mean and how you should think about them. So the first option is the Genesis dir. So basically it is the output folder, the output directory where you want all the things that this command will create to be put. I want it to be on this folder, on this directory, the cluster directory, that is where I'm going to run this command, so everything will be put there. Number of Genesis keys, this takes an integer, and as I said, I want 2 Genesis keys, 2 delegates, 2 block producers, 2 delegate nodes. And the start time of the system, this is the time that you set for the system to start producing blocks. And in this case, this is a good opportunity for us to remember that Cardano CLI allows for this compounding of commands. So we can leverage the date command and tell it that we want the date in UTC, and we're going to tell it that we want the date to transform it into now plus 5 minutes. So what we are saying here is that our system should start producing blocks in 5 minutes, and we are formatting the output so that it matches the CLI requirements, which is exactly like this. Let me just get there, and this is the output that the format that the CLI is expecting a UTC time, and it is expecting with this specific format. So note that if you don't specify the date, the default will be now plus 30 seconds. So you will need to move very quickly. Now let's move on. The supply parameter, the supply option here. The supply is the amount of ADA that you want to be available at the Genesis UTXO right away when the system starts. Note that this is not the maximum supply of the system. The maximum supply when you are using create-cardano is hard-coded to be 45 billion. We have other commands that allow you to modify that, but when you are using create-cardano, it is hard-coded to have 45 billion ADA so that it matches what we have on mainnet. So what I'm saying here is that I want 30 billion ADA available at the UTXO on Genesis from Byron era. The difference, the 15 billion ADA that are missing here, will be available on the reserves once we get to Shelly. This is what this supply means. So again, we are saying that we want to have the security parameter to be 45. And here is when we talk about the slot length. So this will give us 450 slots per epoch in Byron and 9,000 slots per epoch in Shelly and Plus. But here we are saying that our slot length in Shelly, this is important, this is in Shelly, our slot length will be 1/10 of a second. This takes the time in milliseconds. So the duration in milliseconds. So when we say 100, we are actually saying that it is 1/10 of a second. So our Shelly slots will last 1/10 of a second. That means, because of that 1:20 ratio, that our Byron slot will last 2 seconds. So now we move on, and we are gonna keep the slot coefficient on 5%. And as always, you want to provide the testnet magic and the path to the template files that we just modified a minute ago. So let me just run this command, and after I run it, I will have 5 minutes to start my cluster, because this is what I am saying here. Of course, I could modify it, I could give me more or less time. The default is 30 seconds. So now, just for some sanity here, I'm going to move the configuration file to the configuration folder together with the Genesis files that this command created. So from there, we are ready to just, let me just, again, some sanity here. I'm going to move my delegate keys from the delegate folder that was automatically created by the create-cardano command. I'm going to move them to the BFT0 and the BFT1 nodes so that I can have them in this corresponding delegate nodes. And now I'm going to very briefly create a couple of scripts that will allow me to run and restart when needed these nodes. So we have this BFT0 will run in port 3000. And BFT1 will run in port 3001. Reference to the delegation certificate, to the signing keys, and we are saying that the database is going to be inside the BFT directory and all of that. So we are ready to give operational executable permissions to our scripts. And from here, we are ready to actually start our nodes. And with that, we will start our system once we reach start time. So let me just get to cluster BFT0 here and start the node. The node will idle until we reach start time. And let me get here to cluster BFT1 and run the node from here, and we are just waiting for start time. So let's see what is start time in our system. So our system start time is set to be 15:45 UTC. So it should be in more or less 1 minute from now. So one thing that we could do while we wait is actually export our Cardano node socket path environment variable. So you could come to home and use Atom to edit your bash RC file. I'm gonna export this. I have already done that. So now it would be time to source bash RC file. So now we are starting to produce blocks. So we can now do Cardano CLI query tip testnet magic 42, and we see that our system has started. So congratulations, we have a cluster that is running, producing blocks, and we can start having fun with it. And actually, one thing that I'm going to do is keep it just like this so that we see the chain moving. Of course, we have the logs, but we have useful information here for later. Now we have created our cluster. Everything's cool and fine. So we should have a 30 billion ADA available for us. And the thing that we are going to do now is to actually move those 30 billion ADA from the Genesis UTXO where they are right now to regular UTXO.